Welcome to the Season 3 of Maker Club by EEFocus in partnership with the Hackaday Prize, a world-renowned hardware design contest, and DigiKey, a global leader of distribution of electronic components and automation products worldwide. As our long-term partner, DigiKey would like to work with electronic engineers around the world to create and change life with technology constantly. Let's discover the splendidness created by makers together. Mr. KATSUDA from Kyoto, Japan is a professional engineer specializing in music software, motors, and sensors. At work, he excels in handling various projects in these fields, and in his spare time, he enjoys building robots, inventing original electric musical instruments, and creating artwork. As a professional engineer of music software, motors, and sensors, please introduce your current focus area.
I am making communication robots that can talk to children and elderly people, in addition to playing musical instruments and singing. My robots will be useful in kindergartens and nursing homes. They can be placed in the recreation room to please children and the elderly people.
What are your strengths in music and electronics? How do you combine the two to form the robot band?
I earned a master's degree in computer science in the United States and also received training in music theory at vocational school. Music can be expressed mathematically, so it is compatible with programming. My comprehensive know-how is not only about the separate knowledge of robotics and music, but also about how to combine them to realize automatic performance. For example, in order to avoid increasing the burden on the robot, I minimize the movement of the servo motors during performance by adjusting the appearance frequency of musical notes and positioning the instruments.
Specifically, how do you control a robot to operate a musical instrument? Especially when it comes to strength and precision, how is this possible with microelectronics?
By connecting each robot in the robot band to one personal computer, synchronized performance are possible. The computer converts the music information written in the MIDI file into information about the robot posture. That is the angle of the sub-motors. Then data is sent to the robot, and the controller built into the robot controls the sub-motors. In the case of singing robot, a computer converts musical information into sine waves, which are then sent to a conversion device and converted into a human singing voice.
What kind of electronic knowledge and framework would be used to build such a band?
My knowledge of electronics includes servo motor control for robots and sensor technology for original electronic musical instruments played by robots. For control, I use Arduino and Japanese controllers. I wrote a computer program in C++ to synchronously control the controllers of each robot.
In the process of building such a robot band or procuring related parts, how do you feel about the local industry and industrial chain?
In Japan, in addition to procuring parts at the nearest electronics town, many people also use mail order. Popular mail order companies are Switch Science in Japan, AliExpress in China, and DigiKey in the United States. All of these have Japanese websites. Each site has a large selection of products, and there are parts that can be purchased on that site. For example, I once tried to purchase a sensor but found out that it was only available at DigiKey. Although it was a Panasonic product, it was not sold to general consumers, and even though it was a product from a Japanese manufacturer, I had to re-import it from the United States. DigiKey offers a wide range of products. It is convenient when I need parts quickly.
What directions do you think the robot band will continue to extend in the future? Are there some more novel and interesting directions budding?
In addition to playing musical instruments and singing, The latest version enables voice communication and object recognition using a 3D camera. I have begun using it experimentally in the recreation room of a senior citizen facility. The functions use AI technology. Now, the robot joins in the chat with the elderly, acts as a singing reader, and plays nostalgic music with acoustic and electronic instruments.
As a maker, what do you think are the highlights of the maker competition, including the music robots?
It's about creating something that is actually useful in the world. My musical robot aims to be put to practical use in recreational activities at kindergarten and elderly care facilities. In Japan, while the number of elderly people is increasing every year, the number of children is decreasing. Therefore, it is necessary to use robots in the nursing care settings.
Compared with the creation of other similar forms of works, what more impressive key points should be paid attention to?
The advantage of my automatic performance robot system is that it's easy to create operation data. Robot1 data is created in MIDI format and can be easily made using commercially available sequence software.
About your robot band, it looks interesting. May I ask, where is the source of such ideas? What are the features worth mentioning again? Why the combination of the two, rather than robot fighting, robot painting, etc.?
I used to create fighting robots. They usually have a crude crane-like appearance, and their functions are limited to winning. I was obsessed with cute looks and interesting features, but I couldn't win because of that. The robot with extra things will lose. I thought I could satisfy these desires by creating a musical robot. I found that was what I wanted to do.
Is the music robot or the process of creating music limited by some technical reason? In microelectronics, what needs to be improved will make creativity and innovation more interesting.
Currently, instruments are limited to percussion instruments, as they are played by moving the robot's arms up and down. In order to increase the variety of tones, I plan to experiment with instruments that are played by blowing, like wind instruments, and instruments that are played by picking, like string instruments. Another point is that the operating speed of submotor makes it impossible to play fast tempo songs. This problem can be solved by using an expensive submotor, but it may be a little cheaper to use a solenoid.
What is the local impact of music robots?
I exhibit at local festivals and events for children. I believe that by showing children robots, they will become interested in science and technology. If I expand my perspective a little, even people who don't understand the local language can watch and listen to my robot performance.
Music as a kind of art needs constant precipitation and refinement in order to make progress. However, electronic products such as motors and sensors, the iteration and breakthrough of technology, will be relatively fast. From a maker's point of view, what do you think of robot bands, and will there be more advanced robot bands in the future, such as more precise control?
Servo motors and sensors have delays that affect the accuracy of the timing of musical performance. However, this inaccuracy is now playing a role in giving a sense of humanity to these mechanical robots. People don't feel humanity when things move too precisely. In the future, I will need to continue developing the system in a way that is both accurate and humane.
Finally, whether it's a musical robot, an original electric instrument, or some electronic artwork, where do you think the maker's spirit is best represented?
With their cute appearance and movements, the robots play music and bring smiles to children and the elderly. I think that in order for robots and musical instruments to be accepted as companions, it is important to have a friendly appearance and human-like movements.
DigiKey.